Welcome to Math 1342. The purpose of these videos is to get through the material in bite-sized chunks, if you will. My plan is to make most of the videos between 15 to 20 minutes. Maybe shorter if you're like at the tail end of a section and I just couldn't squeeze it in. But my goal, again, to make these videos between 15 to 20 minutes. So you can watch one, take a break, watch another if there's another that's needed for the section, etc. If you're in like a dual credit section of mine, these will probably be different than what you hear in class. They're meant to be a standard version, so the examples may be slightly different. I may say things a slightly different way, but nonetheless. I'm kind of doing just one set of videos for all, so I don't have to worry about doing videos every single semester. But again, nonetheless, that's the purpose of this set of videos. So let's get started. As Mary Poppins says, the beginning is a very good place to start. So section 1.1 is going to be more of an overview of this whole course. We're going to be doing lots of things, whether it's probability or inferencing or whatever the case may be. A lot's going to go into stats. So our purpose is to kind of just give an overview, say this is what we can do with it, and then go from there. So let's start. Data consists of information coming from observations. Actually, let me switch colors here. I'm going to make this to where it kind of stands out a bit. So, data consists of information coming from observations, counts, measurements, or responses. Now, data is basically anything. Anything you do produces data of some sort. In the world we live in, anything we do produces data. I'm sitting here doing this video with an Apple Watch on my wrist. I'm moving my hands and saying, hey, he's moving. That's calories he's burning. That's data. Am I thinking of that normally? No. For that instance, yes. But everything we do in today's world produces data of some sort. You're like, no, it doesn't. Me walking down the hallway doesn't. Is your phone in your pocket? Is your health tracker turned on? If so, it's counting your steps. You're producing data. Anything we can count produces data. So, statistics is the science of collecting, organizing, analyzing, and interpreting the data in order to make decisions. So, like I said, everything we do is producing this data. It's just a continuous string of data being produced daily. 24 hours a day, 7 days a week, 365 days a year. Producing data. Statistics is the science of actually analyzing that data. Now, you may be like, I'm not looking at the steps I'm walking in a day, but you could. Statistics would be, I want to analyze the average steps I walk per day. Hey, I walk 10,000 steps a day. Is that unusual? You could see. Or what's the probability I'm going to wake up and walk 1,000 steps today? Using the data you've collected, you can answer that question. So that's what statistics is. It's really powerful, but it's also dangerous. Statistics, you can spin them in any way you want to spin them. You can use it for good. You can also use it for bad. Whoa. So there's two types of data sets. You can get data from a population And this would be the collection of all outcomes, responses, measurements, or counts that are of interest. So if you get data from a population, you are getting every single thing that you want. If you want to look at the average size of the average length of carrots sold in the supermarket, then that means you have to get the average length of every single carrot sold in every supermarket in the world. That's next to impossible. Yeah, you're right. It pretty much is. So, in that case, we'll settle for a sample. A sample is a subset or part of a population. So what do we do with all of these things? What do we gain from them? Well, in a population, you can gather parameters like mu. And you don't have to know these for chapter 1, but as we go through the course, you will need them for sure. But you can get things mu. Mu is a population mean. Maybe you want to know the variance. How much does the population vary? But typically, variance units, we'll talk about this in chapter 2, but variance units are squared. So if I wanted to know the average income, I could quote the mean, and I could say, oh, but it's got a variance of $250 square dollars. You're like, what the heck is a square dollar? So if we take the square root of the variance, we get something called the standard deviation. So sigma is the population standard deviation. We could have something like P. Or I'm going to call this P no cap. You're like, wow, P no cap. Why? It just looks like a P. You'll see why in a second. This is the population proportion. Capital N is the population size. Now, we can take all of those and get similar things from a sample. Because, like I said, I want to go to every supermarket in the world and measure the length of every carrot they sell. That's too much work. Ain't nobody got time for that. So I do a sample. Well, X bar is a sample mean. S squared is your sample variance. S is your sample standard deviation. I'm going to abbreviate. P cap is your sample proportion. So see where I'll say P cap, P no cap. If I'm talking about P cap, it's a sample. Which means it could lie. It could be extreme. It could lie a little bit. But P no cap, that's no cap. We're not lying there. So P cap, P no cap. Okay, and then N is our sample size. Now, these are all of the possible ones. There's rho and R for correlation. These are just some of the common ones we'll be using here at first. So now, what do we do with these? Well, for the first few chapters, we're going to be going from a population to a sample. This deals with probability. What's the probability that I walk 5,000 steps today? So that's going to be done in chapters 3 and 4. In chapter 2, we're going to kind of learn how to calculate these things. Mean, variance, standard deviation, a proportion. The size, I think you kind of know. You just count it up. But chapter 2 is going to be spent on how do we calculate them. Chapter 3 and 4 is going to be probability. But then often we don't know things about the population. I don't know how long the population carrot is sold in a supermarket because by the minute some farmer is pulling up another carrot, there my population just changed. So we typically use things with a sample to tell us something about a population. We use these sample statistics and this helps us to gain information about a population. By us studying the average length of carrot, we're gaining information about the population of carrots that are commercially sold. So, population, you deal with parameters. That's how you can remember it. PP, population parameter. So, mu sigma squared. I know it looks like an O with a square on it. That's a sigma. Don't call it O squared. That would not be very sigma. We want to be sigma in here. Sigma squared, sigma, P no cap, and N. Sample, these are called sample statistics. This is a numerical description of a sample characteristic. So the thing to remember here is that population parameters are always the same. Population parameters never change. But sample statistics do change or can change, I should say. I'm not going to say they for sure change, but sample statistics can change from sample to sample. So the second half of the course, if you will, is going to be dealing with this top piece. So we're going to deal with statistics mainly in the second half of the class. Second half of course. Because statistics are used to estimate parameters. You're like, well, what do you mean by the second half of the course? I mean, this is going to be chapters 5 through 9. So there's 9 chapters in here. 1 through 4 are going to be either learning about how to calculate these values. 3 and 4 is probability. And then 5 through 9, we're going to be using the statistics to get parameters. Okay. So just to kind of set the stage, let's look at an example. In a survey, 720 employees in the U.S. were asked if they thought their jobs were highly stressful. Of the 720 respondents, 446 said yes. Identify the population in the sample and describe the sample data. Okay, so we want to figure out what's population, what's sample. To answer the question, what are they studying? Who are they surveying? They surveyed 720 employees in the U.S. Well, the 720 is our sample. The employees in the U.S. gives us our population. So our population would be all responses. Let me back up. I'm going to rewrite this to make it a little bit more clear. The population would be the responses of all employees in the U.S. All right, well, wait a minute. What's the sample then? The sample would be the responses of the 720 surveyed employees in the U.S. Okay. So it says describe the sample data. Well, what can this data tell us? That's what it means by describe. What can it tell us? Well, we know that 446 said yes. I could do some quick math over here. 720 minus 446. Let's see, that's going to be 4, cross that out with a 1, cross that out with a 6. It's going to be a 7. 274. 274 said no. So that's basically our data. 446 said yes, their job is highly stressful. 274 said no. I could take that a step further. What if I wanted to look at the percent? Because I want to report it in like a news article. Well, a percent is nothing more than a part of the whole. So what percent said yes? Well, 446 said yes. The whole was the 720. So as a decimal, that comes out to, I'll do some math magic here, 0.619, which is 61.9% said yes. So now, this proportion here, would it be P cap or P no cap? So is it P or P cap? Well, you have to think, what is our denominator? Our denominator is 720. The 720 is the surveyed sample. So that means this is P cap. 720, that's what was surveyed from the sample. So this is P cap or P hat or whatever you want to call it. It's not P. It is a population, it's a sample proportion. Okay, let's look at the next one. Angelina College has 5,148 students, of which 1,699 are full-time. Do these numbers describe a population parameter or a sample statistic? Well, let's look here. The 5148, what is that? That one is going to be our population. So this piece where it says of which 1699 are full time, this is part, or let me back up. This is based on a parameter which means these numbers describe a parameter. So these three dots mean therefore it's a population parameter. Now, if it had said of 100 students, 17 were full-time, well, okay, the 100 is not the whole, so therefore it's a sample statistic. But we're going to assume AC has 5,148 students. That's the whole population. I know I said this video is going to be less than 20 minutes. I'm sorry. But we're almost done. I don't want to stop it here and have like a 3-minute video. So anyways, there's that example. This one is a population parameter because it came from the whole shebang. Okay, last little bit. So there's two branches of statistics. We have descriptive statistics, which involve the organization, summarization, and display of data. Display means pictures and all the pretty colors. But then we have inferential statistics. That is the second branch. This involves using a sample to draw conclusions about a population. So in chapter 2, we're going to learn all about descriptive statistics. Mean, variance, standard deviation, range, median. Those describe the data. But in chapters 5 through 9, this is where we're going to do inferential statistics. We're going to try to make conclusions about the data. Okay. So, last example. Angelina College has 5,148 students, of which 1,699 are full-time students. Do these numbers describe a population parameter or a sample statistic? Wait a minute. We just did this. Oh, I see what it's doing now. Okay. So they want us to take the same example that we just did and break it up. So the question's kind of worded funny. But we want to pull out what is descriptive in this problem and what inference could you make because of it. Okay, so what are some descriptive pieces that I can pull out of this problem? What are some facts? Think of descriptive as cold, hard facts. Well, AC has 5,148 students. That's a cold, hard fact. Students, not students. And then what else do we know of that? Of which 1,699 are full-time. That's descriptive. We're just spitting out facts. That's all we're doing. Inference is like, well, what could I say about that? That doesn't use data. Inferencing, you're wanting to use the data, but you're wanting to make a general statement. What could we say in general with this data? About the majority of students at AC. What do most students at AC do? We could say the majority of AC students are they full-time? Is 1699 the majority of 5148? No, they're not full-time. They are part-time students. Did the problem tell us anything about part-time? Did it spit those facts at us? No. That was our inference that we drew from the data. So now you've kind of seen the overview of what stats is all about. Hopefully I didn't scare you off on this first video. But that's all section 1.1 is talking about. So stay tuned for section 1.2. But in the meantime, remember, you are loved. You are created to do wonderful things. And you are awesome. Always believe.